I'm starting from the video. Please choose on the video. Wait. Okay, let's wait for the last minute. I'm checking whether they are coming or not. So let's start the class without any because I don't think that. Let's, okay, let's start the class. Let's discuss the new topic that we're going to see. Right. So this topic is it basically lies under the fundamental topics of the electricity, like electric charge, electric current, electric potential. So these are the topics which are very basic and require understanding so that to understand the further topics, right? Just like we have done in the light chapter, we have to understand the reflection refraction to understand the image formation, the image formation by lenses, by mirrors, right? So similarly, electric potential, electric current, electric charges are those fundamental topics which are required to understand the coming topics like resistivity, Ohm's law, combination of resistors, and all the things. Clear, everyone? Sure.
Yes.
Right. Now let's understand the electric potential. So basically, electric potential is the main physical quantity, and from electric potential, there is a new quantity is developed that is called potential difference. So in real life, the use of electric potential is nowhere, but in the real life, use of potential difference is everywhere, right? So we'll discuss what is the use of potential difference and how do we differentiate. Mariam, please check your camera. I'm not able to see your video. Actually, your screen is completely blank at my end. I think so. Please mark the integrated webcam in the video setting if you have choose any other camera.
Sir, there's only one camera.
One camera. So it's
Yeah.
still like is your video is your camera showing that your face at your end?
Uh, mhm. Sir, I also cannot see.
Chalo, yes, that's why I'm saying. So that's why your video is not. If you have checked this thing, so you can. Okay,
Yes.
Mariam, okay, please look into this. Okay, Mariam. So before like in the next class, try to fix this. Okay.
Yes, sir.
If your camera, like maybe you're from father or if you have elder sibling, maybe your sister or brother is out. Let's start.
Yes, sir.
Okay, so now let's understand what is electric potential. Suppose that in the last class I have told you one example that if there is a heater switched on, if you switched on a heater in a room, so there is a region confined in which that the heat is basically experienced, the warmness is experienced. Yes or no? That warmth is experienced, right? So similarly, electric potential is also such okay. So similarly, there is a region that is developed around the electric charge. That is called electric field. I have told you about the same in the last class. Do you remember, everyone? That if there is a charge placed in the space, so it will basically create a region in which the electric field can be experienced. That electric force by that charge can be experienced, just like the heat, right? So that would be a very certain region, right? So suppose that this is a positive charge, okay? This is a positive charge, and one more charge is basically present somewhere in the space at infinity. We are just assuming that if that charge is at infinity. Okay? Am I clear to all of you?
Yes.
Sure. Okay. So that is hello Elvina, Assalamu alaikum. How are you?
Walaikum salam, sir. I'm fine, thank you.
Okay, that's great, Elvina. I've just started the class, okay? So I'm just explaining what is potential, electric potential. Okay, please switch on your video. Okay. So I've told you that electric charge, if you place an electric charge in a space, so you will basically, so there will be a region in which that electric force by that charge can be experienced. That is your electric field, right? And suppose that at infinity there is an one more electric charge present positive. So everyone see this thing. If this is positive electric charge, so will it attract this charge if I basically get closer to this charge, or it will repel? What is the consequence of that? If I take this charge close, okay, I said repel. Mariam, Zainab, and Alvina, what would
Repel.
happen? Repel. Okay. Alvina, Mariam.
Yes, sir.
What will happen if I take this charge nearer to this electric field region? Will it repel or will it attract? Okay, let me think. Go ahead. Did you
It will
attend the last
repel.
repel? Okay. Okay. So when you take this charge closer to this this positive charge, so suppose that there is a point in this region called A, right? So obviously, if this is a positive charge, it is also a positive charge. It means that it will repel each other. It means that you have to apply some force. You have to do some work to basically place this charge in this region. Suppose that you have two magnets, both are not full. You will basically exert some force on the magnets to basically get closer, to make the magnets a little bit closer. Yes or no? Do you do? Yes. Do you have to do some work done? Similarly, in this, if you have to place this charge in this region, so there will be a repulsive force. So the work done that you are doing to take the charge from infinity to point A is called electric potential. The work done to move a charge from point infinity to point A in an electric field is called the electric potential. Am I clear to all of you? Please do let me know last time.
Sir, can you repeat what?
The work done to move a charge from infinity to a point A in the external electric field is called the electric potential. Here, it means that when you take that charge from infinity to point A, you have to do some work done. If you are carrying some handbags from a market to your home, you have to do some work done. Your energy is getting exhausted. Some part of your energy is getting exhausted. Right or no? Yes or no? So similarly in this, if you are taking a charge from infinity to point A, so you have to do some work done, right? So that work done in the external electric field, because this charge has some electric field, because the charge point A is present in the point in the electric field region. So that work done is called as electric potential. Am I clear to all of you? Please do let me.
Yes.
Maria, Aisha, Zainab, Alina.
Yes.
Sure. ठीक है? ठीक है? So that is it. So let me write it over here. Electric potential. So what are the definition of electric potential would be electric potential defined as the at a point is electric field defined as the work done in charge unit positive charge from infinity to that point. Okay, everyone? Right here to all of you, please do let me know what's the. So this is the explanation of the electric potential. When you take a charge from infinity to a point that is placed to a point that is present in the external electric field of a charge. So that work done that you are doing to carry a charge from infinity to that point is called electric potential. Am I clear to all of you, Zainab, Alvina, Mariam, and Aisha? Okay? Sure. Now, the next property of the electric potential is a scalar quantity. It means that it only depends on the magnitude, right? Scalar quantities are those quantities which depend on the magnitude. So that's why electric potential can only be, you can say, affected by the magnitude, right? No effect. There is no effect of the direction on electric potential. So electric potential quantity. Okay. Next point about electric potential is which one? That electric SI unit of the electric potential is volt. Okay. It is capital. Okay. So this is the SI unit of the electric potential. Please do let me know everyone if it's clear to you or not.
Yes.
Clear out so far, Alvina, Mariam, Zainab, Aisha.
Yes,
No,
sir.
sir.
Sure. Okay. Now let's talk. So this is all about the electric potential. So electric potential is not that much difficult to understand. The next thing that is coming, the potential difference, which is very, very important to understand, because all the things that we are going to do in the coming topic, that is potential difference. Okay, that's why it is important. The only definition is there for the electric potential, not more than that. Next thing that we are going to discuss is the potential difference. Potential difference. Now let's understand this. What does it mean with the help of this diagram? Suppose that everyone, this is a diagram. Okay, suppose that, okay, so this is one charge. Suppose I'm taking one more positive charge, right? One more positive charge from infinity to a point, certain point B, suppose in that region. Okay, that is, am I clear? So potential difference. What does it mean? Potential difference means suppose that these 2 points are there. So we assume this thing that if the point work the basically to carry a charge from infinity to point A is greater than B, right? So the difference between the 2 points, it means that when you take a charge, suppose this is let's take one thing. So in the simple words, the work done to carry a charge from A to B. The work done to carry a charge from A to B. First, you have placed both the charges over here. So you're just now next thing is that the potential difference concept starts from after placing these two charges in the electric region. When you carry a charge from point A to point B, right? So the work done required to carry this charge from this point to this point is called potential difference. Am I clear? The work done required to carry this charge from point A to B is called work done. Clear? The work
Yes.
done. Okay. In this, two charges are involved. In electric potential, only one charge is involved. That is at infinity, right? So this charge is basically that is present, that is not moving at all. So in this electric region, we are just considering these two charges that is coming from the infinity, right? So in potential difference, two charges involved in the explanation. That is point A charge from another point that is coming from B. So you're coming to B and one charge coming to A. So the work done required to carry the charge from A to B or B to A, depending on the higher potential. So that work done is called the potential difference across the two, between the two. Now let's understand the potential difference in terms of water. What does it mean actually? What is the basic need of the electric potential? Suppose that everyone, this is a tank, water tank. Okay? Two water tanks are there. One is full, like almost filled. One is like almost like empty. So there is a pipe connected between the two tanks. What will happen? What will happen?
Water will flow
So can you repeat again?
to the
I'm
other
saying, okay, okay. I'm saying that two water tanks are there. One is completely filled, almost, and one is like almost empty. Okay. I'm saying that if I connect both the tanks with a pipe, what will happen? What is the direction of water? From higher to lower or lower to higher?
higher to
From
low.
higher to lower.
Okay, Alvina said higher to lower. Aisha said higher to lower. Zainab said higher to lower. Mariam, what's your answer? Mariam, are you there?
Yes, sir.
I'm asking what will happen in this case, water tank case.
Um,
Okay, let me tell you. So basically, water will flow through this pipe in this tank until they are equal. Yes or no? Once they'll be equal in the height, there will be no flow of water at all. So basically, the potential difference is the consequence for the flow of electric current. Potential difference helps to flow the electron from one point to another point due to the difference in potential. It means that suppose point A is at higher potential, it has more work done that is required to take from infinity to point A. And B is at lower potential. It means that the work done required to carry the infinity to B is a little bit lower than that. So if you have a difference between these 2 points, so the flow of electron would be from higher to lower potential. Just like the water. If there is a waterfall, the water will fall from the higher point to the lower point, yes or no, just like in the waterfall. So that's the same concept in the potential difference. Here, Mariam, Aisha, Zainab, and Alvina.
Yes.
Okay. Okay. So this is for the explanation. I'll explain this thing as well in the question. Let's do. Let's write down the definition. Okay. That is the A point. So there are more characteristics of potential difference as compared to electric potential. Okay. So the potential difference between 2 points. Okay, everyone. Do not ever write this thing in the exam between like write it completely. I like we are basically making notes, so it is acceptable right here. But in the exam, you have to write it completely because sometimes students say that we write like we are very habitual of writing this thing like that. But if you write it, you will lose marks. Okay, so please be aware of that. Okay, 2 points. And then 6. is defined as the amount of work done in moving a charge or unit charge. Let's say unit because we are using the unit thing. Okay. Unit charge from one point to another point to the other. Okay. That is the electric potential difference definition. Okay. So if you write it in terms of the formula, that is work done by charge. Potential difference is defined as the work done to move a charge from point A to point B. Okay. Basically, a unit volume charge. Clear, everyone? So this is the formula where, so I'm writing as well that V is basically the potential difference of any 2 points. So V minus V, V1 minus V2, where, so I'm writing it over here, that is V1 is greater than V2. If V1 is greater than V2, then I will get the potential difference as positive. So that's why I have to show that it is V1 is greater. If I write V2 minus V1, then I have to write V2 is greater than V1. So that the like, potential difference comes out to be positive, right? So that's why I'm writing so that it looks like logical. Okay, chalo, that's great. Next point is, the potential difference is also called as voltage. In the normal language, that is called the potential difference as voltage. You must have heard this word as voltage, voltage drop. There's very low voltage in the home, or right? You must have heard this thing very common, like frequently. Have you heard this thing, voltage? Right, 220 volt is coming in your home. That is the standard voltage that is there in the home, right? In the domestic circuit. Okay, okay. So potential difference is also called as volt. Okay. Next point about the potential difference is, so see this thing, everyone. When you add or subtract the two quantities, so the unit is not going to change at all. Right now, we are subtracting the 2 points. Both are basically electric potential. So the voltage will remain same. The unit will remain same. It is not going to change at all. Right? If you say this thing that suppose I have 5 liters of milk and I've given 2 liters to someone else. So remaining milk would be 3 liters. So unit is not going to change, only the magnitude is going to change. Okay, Albina, Zainab, Mariam, Aisha, and Abdul. Okay?
Yes, sir.
Sure. Okay. So whenever, keep this thing in your mind, whenever you are adding or subtracting the same quantity, so the unit will remain. Okay. D would be, okay, so D now, so the potential difference is used, or you can say is measured by the instrument called voltmeter. Okay, potential difference is measured by the instrument called voltmeter. Okay. volt. Okay. Now let's talk about the voltmeter thing. That voltmeter is only connected in parallel combination in the circuit. I will explain in the further topics. We'll be studying the combination of resistors, and that is parallel and the series. So right now, just understand this thing that voltmeter is always connected in parallel in the circuit. Okay. So we'll explain in the next part the combination. F part. F part is voltmeter should have high resistance. So these are some properties that you have to understand and you have to remember, because in sometimes that question says that what is voltmeter and how it should be connected in the circuit. Right? It is a two-marker question. So voltmeter is all what voltmeter is an instrument to measure potential difference between 2 points. Voltmeter is always connected in the parallel combination in the circuit. Okay? So that's how you'll get the 2 marks. 2 points, 2 marks. Enough. No need to write in the single line. 1.1 bullet point. Voltmeter, define the voltmeter. Second point, it is connected in parallel combination in the circuit. Okay? Like that. Next point is that because if you understand that why it has high resistance, because that is the topic of 11th 12th class. So there is no need to understand right now, because it's already present in detail in the 12th standard. You will study that. Okay? Right now that will be of note. Okay? Voltmeter. Should have very high resistance. Okay? Am I clear to all of you? Please do let me know. Is there anyone who is having doubt till now?
Done.
Sure. I'm asking last time, do you have any doubt till now in the topic of electric potential and potential difference?
No.
No, sir.
Chalo, that's good. Okay. Now let's define what is 1 volt actually in terms of joule and in terms of coulomb. Okay? Because charge work done is joule, charge is coulomb. Okay? Because sometimes question says that like 2 marker comes into the exam that define 1 volt. So in that basically scenario, you have to define the thing like you have to define the 1 volt as the potential difference between 2 points. Said to be 1 volt if 1 joule of work is done in moving 1 coulomb of electric charge take electric charge from 1 point to another.
Sir, what is
Right.
1 I?
1,
One
this
I.
one. It's not 1 I, it's 1 joule. Joule, J.
Okay.
1 volt is equal to 1 joule by 1 coulomb. That's how it is defined. Please do let me know everyone if it's clear to you or not. Aisha, Mariam, Zainab, Alvina, Abdul.
Yes, sir.
Sure. Just allow me.
Yes, sir.
That's how it is defined. Okay, now let's do a question based on the electric potential topic. Okay, so there will be no numerical from the electric potential. The numerical will come from the potential difference. Okay, because there is no numerical in the electric potential. Only definition is there. They might ask you the definition, SI unit, or the nature of quantity, whether it would be scalar or vector. Okay. Now let's do this question. Okay. So as we can see, this thing. Let me explain this. That is, question is saying that how much work is done in moving a charge of 2 coulomb from a point at 118 volt to a point at 128 volt. It means that charge is given to you, that is 2 coulomb, yes or no everyone, right? And V1 is at 128 volt. Okay. V2, that is the another charge that is at 118 volt. Okay. So question is, in this thing, you can see this thing that potential difference is not given, but the actual potential of the points are given. Am I right, yes or no everyone? Okay. From these two quantities, from these two values, you have to find the potential difference. So how you can find out the potential difference? Potential difference is nothing but the V1 minus V2, right? So as you can see this thing that V1 is at higher potential, so I have to take the higher potential as V1 and lower potential as V2. Okay. So 128 minus 118. Am I clear to all of you everyone? That is nothing but 10. Okay. 10 volt is the potential difference between the 2 points. Am I right or not, Petro? Clear to all of you?
Yes.
Did you get
Yes.
how to calculate the potential difference if these two potentials are given to you? In some of the questions, they will give you the potential of each point, so you have to calculate the potential difference just like that. You have to assume the higher potential at V1 or VA, whatever it's up to you, right? And you have to, the lower potential will get subtracted from the higher. Or in some of the questions, they will say that voltage across the points are 2 volt, 6 volt. It means that they already said that is potential difference. Voltage is the potential difference. Or if they say that thing, the cell or battery, it means that they are also pointing towards the potential difference. The value given to you is also potential difference, not potential. Final value is already given if they say battery or a cell. Am I clear to all of you?
Yes.
Aisha, Mariam, Alvina, Abdul?
Yes, sir.
Sure, that. Okay. So now we know the value, sorry, formula, that is V is equals to W by Q. So I'm going to substitute this over here. That is W. I need W. That is V into Q. What is value of V? That is 10 into 2. That is coming out to be 20. What is the SI unit of the work done?
Joule. Joule.
Oh, Okay, Mariam said Joule, Jannat said Joule, Aisha, Albina, Abdul.
Yes,
Joule.
Joule.
Okay, Aisha said Joule. Albina, what did you say?
Joule.
Okay, Abdul. Okay, it seems like he's not in touch. That is 20. This is your. Please do let me know, everyone, if it's clear to you. Right? So every question is giving you two individual potential. So it means that you have to calculate the potential difference by subtracting the lower potential from the higher potential. Am I right, everyone? Is this clear to all of you? Do you have any doubts still? Do you
Yes,
still
sir.
any doubts? Sure, that's it. Sure. I'm giving you one question. Please try this question. That's a very basic question. Okay, just like try to implement the formula, you will get the answer. It's completely based on the formula. Please note it down and let me know if you are done with that. So this is the question. Please do let me know the answer, everyone, in the chat. Please answer me only in the chat. Okay, I got the first answer by Zen. Okay, then. Okay, Albina. Aisha, Mariam. Okay, Mariam. Aisha, what's the answer? Aisha,
Sir, I send you.
I didn't get the answer. Please send it again. There is no answer in the chat. Please check it. Okay, now check. Okay, then let's solve it together and you can verify from it. It's very basic. Like, the question is saying that how much energy is required is given to each coulomb of charge passing through a battery of 6 volts. It means that it is saying it is using a battery word. It means that it is actually a potential difference. It because battery is a basically 2 point connection. Okay, one is that higher potential, another one is that lower potential, right? So it is already saying that the potential difference between the 2 points is 6 volts, right? Next is charge given to you is 1 coulomb. Each coulomb, it is saying each coulomb. It means that 1 coulomb of charge. I think so that's why Albina, you got confused here in the each coulomb word. That's why you got 36. You might have like misinterpret that like as 6 coulomb. Yes, Kalvina?
Yes, sir.
चलो ठीक है, कोई बात नहीं, ठीक है. So if you basically substitute the values over here, that is V is equals to W by Q. We need the W, that is V into Q. That is 6 into 1, that is equals to 6 Joule. ठीक है, this is the answer. Please do let me know everyone if it's clear to you or not. If you have any doubt, any topic that is not clear to you now. ठीक है, Alvina, clear? Each coulomb means think that 1 coulomb of charge. ठीक है, how much energy is required for 1 coulomb of charge? So each coulomb, so we have to calculate only for the one charge. ठीक है, 1 coulomb of charge. Sure. Okay, so I'm giving you one. Please do this one. Okay, everyone, after this class, you have an assessment. Please go and check out. Don't miss that assessment, okay? Yeah.
Sir, work done cannot be negative, right?
But work done can be negative, but right now you have to assume that higher potential is to like higher to lower. Work done could be negative. If you are doing the work done in the opposite direction, so the work done could be negative.
Okay, sir.
So, but now you have like in the standard that is not there in the paper, so that's why there's no need to take it as positive or negative.
Okay, sir.
But it could be. Okay.
Okay, sir.
Yeah. Okay, Mariam. ठीक है. Okay. Okay, Aisha. I should always use capital J. Okay. In the joule, because joule is
Okay.
represented by capital. Okay. Because if in this it is acceptable, but whenever you are writing in the exam, always use capital because it will change the meaning. Okay.
Okay.
Okay. Okay. Alvina. Sure. ठीक है. Okay. So question is saying that calculate the work done in moving a charge of 4 coulomb from a point 220 volt to another point that is at 230. Right. So we are assuming that V1 is equals to 230 and V2 is equals to. Okay. So to calculate the V, you have to subtract the lower potential from the higher potential. Okay. Alvina, like we do not assume the negative and positive in this case. Answer the magnitude you get right, but do not use negative sign right here. Okay.
Okay.
हाँ, ठीक है. So that is 230. Because like work done can be negative, and you will understand this thing in 11th standard when you will do the work energy power chapter in the 11th standard. Okay, so that will tell you that how to take that what is negative work done, what is positive work done. Okay, 230 minus 220, that is 10 volt is the potential difference across the 2 points. Okay, and charge is basically is equals to 4 coulomb. Okay, so now simple, just substitute the value in the formula, that is work done by charge. So and you need to calculate the work done now. So that is V into Q. So that is 10 into 4. So that is equal to 40 joules of work done is required. Okay. Sure. That's great. Let's do a last question of this class and then let me know the answer. Do it fast and let me know the answer. I'm testing the questions. Oh, this is a question. Please do let me know. Similar type of question. There's also a similar type.
Sir, can you explain this? I don't know how to solve this one.
Okay, then I'm not worry. To explain, Aisha and Alvina, would you like to answer? Please solve it.
So one second.
Yes, Aisha, you said something, Michelle?
Sir, 1 second.
Okay.
Let me try.
Uh,
Yes, Mary.
sir, I got
In the chat. In the chat. Whatever the answer you get, please let me know in the chat. Okay, Mariam. ठीक है.
Sir, I'm not sure if I did it right, but I did send you the
Okay,
answer.
no, it's not true. At least tell me. ठीक है जाना. Okay. Okay, Alvina. Alvina, that it's no more. चलो, कोई नहीं. No need to. I'll explain.
Sir, I don't.
चलो. Okay. The question is saying that the potential difference between the between the terminals of the battery is given to you. Okay, we need to calculate. Sorry, if the work done is 250, okay, it means that you have to work. Okay, so work done that is required to move a charge from one place to another place, that is 250 volt, and to transfer a charge of that is equals to 20 coulomb. Okay, so just write down the formula. V is equals to W by 2. I need to calculate potential difference. Means that I need to calculate the potential V, right? So V is equals to work done is 250. That is divided by 20. So that is equals to 12.5. Okay. This is the answer. Alvina, you just like multiplied the same, like you have done the same thing in the previous part. Yes, I hear you saying something.
Sir, I got the same answer, but I thought that answer should not be in point.
No. That's fine. That is okay. No need to worry. Elvina got it?
Yes, sir.
Please work in calculations a little bit. And I've seen this thing in like the revision test as well. Okay? Please work on that.
Okay.
Okay. Rana, did you get this point? Did you get the answer? How to solve this? Okay? You need to calculate potential difference. If the work done is given to you, if the charge is given to you, just divide the work done by the charge so that you can get the potential difference across the 2 points. Please do let me know everyone if it's clear to you or not till now.
Yes.
Yes, sir.
Is there anyone who is having doubt till now in the potential difference of the electric potential topic? No? Sure, sure. Okay, so this potential difference topic is done. Okay, and electric potential and electric potential difference topic is done. Basically, in these topics, no, like very very few variety of numericals are there. Only these types of numericals would come in your exam. The numerical will start from the Ohm's law. When you will study Ohm's law, you will study combination of resistors. You will study Joule's law of heating. You will study the electric power, and you will study the how to calculate the electricity bill. These are the 5 topics from the like from which numericals are very and definitely will get the numerical from each of the topics. Okay, so this chapter is completely numerical oriented. So it's a request to all of you, please do not miss any class of this chapter. Like light chapter has some theory, I know this thing. Human is completely theoretical, but electricity chapter involves the theoretical as well as the numerical. Okay? And this chapter is completely numerical oriented. If you understand the theory, then you will be able to solve the numericals. Otherwise, numericals cannot be solved like that. Like it's not like the simple mirror formula lens formula. In this, multiple approaches are there. Okay? In which branch current will be same, in which branch potential difference would be same, in which what will the potential difference, the drop of potential difference and all that. How to calculate the equivalent resistance, how to calculate the equivalent resistance series, parallel. So that the coming topics are a little bit, you can say, uh, confusing and complex. But the thing is that if you understand and if you attend the class regularly, chapter would be very easy. Because magnetics is very easy. The major portion that was tough is deleted. This is scrapped from the CBSE. Like induction current, EMI, electric magnetic induction, AC generator, DC generator, right? AC dynamo. These are the things. So that is deleted from the CBC right now. Only very basic theories left in the magnetics. Only 2 or 3 classes required to complete the magnetics. So I'll basically give extra attention to this topic. Okay? Chalo, that's great. Okay, so that's all for this class, everyone. You can leave the class and please go and check out this. Okay? Chalo, that's great. Allah Hafiz.
Okay,
Thank
sir.
you.
Thank you, sir. Bye,
Welcome.
sir.
Bye. Hello, Hanan. How are you, Vijay? Hanan, am I audible?
Good evening, sir.
Good evening. How are you, Hanan?
I'm fine. How are you, sir?
I'm good. I'm good. Thanks so much for asking. How's the preparation going on for the exam?
Good.
Good. Great. Great. Okay. So let's discuss. Okay, ma'am. So just a moment. And please switch on your start beginning discuss. We'll start this. Okay, and so right now we are here to discuss the, you can say, the portion laws of motion chapter, right? Okay. So let's start the discussion without any delay. Okay, so in this chapter you have scored very well. It seems like your topic, like the concepts are very strong, and all the things are on the right track. Okay, so just let's identify, like to avoid the silly mistakes. Okay, in which portion you can avoid the silly mistakes. Okay, so let's discuss that. Right. So the question number 5 that you have. Okay, so this is clear. So question number 5 saying that a passenger train is moving. Okay, tosses a coin. Passenger in the train basically tosses a coin which falls behind him. So it means that motion of the train is, what would be the correct option? Hanan? You have written C. That is not the correct one, but I'm giving you one chance. In your opinion right now, what should be the correct one? Except C, because you have already checked that.
Accelerated.
Yes, accelerated. Because whenever the toss, the question is saying that when the person tosses the coin, the person is moving with the same velocity, but the coin is in the upward velocity. There is no horizontal velocity. Coin is going in the upward only, but train is going like that. So it means that the body basically is going in the forward direction, and that's why the coin will fall behind that person when it will toss the coin. Okay,
Yes, sir.
shallow that. Next question. So in all the MCQs, you are very right. You are absolutely correct. Okay? And that's a good sign that it means that you are able to tackle the MCQs. Okay? Sure, that's good. Let's identify. So question number 2, you have done very well. You have written the formula, you have written the given thing. That's why I am very impressed. And that is the thing that you are following, that all, like if you even do not, if you basically do not solve the question, so you will get some half mark at least if you write just these things, right? Even if your calculation is wrong a little bit, so you will score some marks, right? Will not be null in the question. That's a good thing. Okay, so explanation was up to the point. Okay. But the thing is that, Hanan, you can also use the bullet points to basically a little bit more improvised version of the answer. Explain the basically conceptual answer. Okay.
Yes, sir.
Yeah, that's great. Third question, that is very good. Everything is written in the format like the given part first, then you have used. Okay, one more thing, Hanan. If you are using, instead of you writing this thing, Hanan, do not write the modified formula first. Always write that V is equals to U plus AT. Then arrow sign, it means that you are basically doing some modification that is equals to V minus U by T. If you want to modify it a little. If you want to basically substitute the value over here, we'll get the same answer. You can also substitute the value over here as well. Just like V is basically 20, U is 0, plus A is your A need to calculate. A is basically 5. Right? So A would be equals to minus. Okay. Okay, sorry, B is 0. Sorry, B is 0, U is 50. That is 0 plus 20. So V is equals to minus 4 meter per minute. Okay. So there are two methods. Okay. If you write directly the modified formula, so there is a little bit risk in that. Okay, Anand? Because
Yes,
sometimes
sir.
like teacher will say that like what is the actual formula that you have used over here. So instead of doing that, you can use this first, then you can modify it if you want. Either you can also substitute the value over here. Okay. Sure.
Okay,
If
sir.
everything was right, your answer was correct as well. I've given you 3 marks. That is very good. Okay. Now, question number 28 was, let's take. Okay. So that is also good that what you have stated the law of conservation properly. Then you have explained that in terms of the example. It is suitable example. That's very good. Okay. So if two cars hit each other, they collide and stick together and move the road. Other one more thing. It's not like it's not the act like it's not the only case that the cars when they collide they will stick together. there is also a chance that after the collision, the velocity of both the car will get changed. So you have written one case. Okay, there might be another case. So if you just write one case, so in that case, there is a chance that teacher will lose, like deduct your mark. I'm not deduct the mark, but there is a chance. For that, you can do one thing. You can give the general example. Instead of going with the specific example, you can do the general example so that it would be applicable to both the things, right? So you will write this
Right.
thing that if they collide, so there is a possibility that the car will stick together or they will move with the different velocities. So you have included both the general things. So both the possibilities there, right? So because if you cannot argue the teacher that why did you cut the mark, so they will say that you have not given the proper explanation. So for that reason, you have to basically include that point. Am I clear, Hanan?
Yes, sir.
Sure. Acha, one more thing, Hanan. Okay, next thing. So this is the third part. Or okay, next is 36 question instead of okay, you have read it 26. So that's why I got confused. So always write the proper question number because teacher, if the teacher sees this thing, they like in the school or in the CBSE boards, they'll get irritated a little bit because they have to
Right.
find that which question it is. So you have to check it. Right. So for that, you have to do a little bit just show a little bit awareness in that. Okay. Now the question number 36. Right. So question is saying that a 5 kg of block is moving with a velocity of 6 meters per second. A constant force is there. What is the calculate the final velocity and the distance covered? Okay. So force is given to you, time is given to you, and the initial velocity is given. First of all, you need to calculate the final velocity. Final velocity you have written over here. That okay. So you have for that you have to calculate the acceleration. So you have calculated the acceleration from the force and mass. That is well and good. That's correct as well. Okay, you got the right one. Then you have basically implemented the equation of motion. Okay, that is V equals to and it is from the first equation and second. Actually, one more thing, Hannah. Always write if you're adding at least write m because after that it think it'll say this is the quantity because if you just write down the number, so there's a chance that they'll just the teacher just find out the way to cut the marks. They are not going to give you the full marks. They just find out to cancel some marks at any cost. So that's why it's up to you that if you want to lose your marks or not. You have written 27 meter, that is well input, but if you write it as well in the bracket like this, so that is also that will look more appealing. Okay, so it look more fundamentally right.
Yes, sir.
Chalo, okay, that's great. Now the next portion we have written over here that is 27th portion. It's not 27, basically it's 37. Okay, so question is saying that a 0.5 kg ball is dropped from a height of 10 meter, assuming no resistance. Calculate the speed of the ball just before it hits the ground and time taken to reach the ground. Okay, so let's understand this thing. So you have calculated the final velocity with which it will hit the ground, right? S is given to you, that is height 10 meter. So you can easily use S is equal to UT plus half AT square. So Hanan, when you will drop the ball, the initial velocity would be 0. And you will drop the ball like that. If you just drop it, so ball velocity will be 0 at that point when you will dropping. So the velocity will gradually increase due to the acceleration due to that, right? So S would be only left with the half AT square, right? So substitute the value over here, that is 10 is equals to half. A is nothing but 9.8 into T square you need to calculate. Basically, T you need to calculate the time. Yeah. Okay. So 10 to the 20 divided by 98 is equals to T square. Okay. So T square would be equals to uh T it would be equals to under root of 20 by 98. So Hanan, that would be T is equals to if you remove that decimal, that would be 200. So 200. So 2 into 100, I can write this thing and I can write this thing 49 into 2. Yes or no?